Chapter 2 Theory of Consumer Behavior. In this chapter, we will study the behavior of an individual consumer. The consumer has to decide how to spend her income on different goods. Economists call this the problem of choice. Most naturally, any consumer will want to get a combination of goods that gives her maximum satisfaction. What will be this best combination? This depends on the likes of the consumer and what the consumer can afford to buy. The likes of the consumer are also called preferences. And what the consumer can afford to buy depends on the prices of the goods and the income of the consumer. This chapter presents two different approaches that explain consumer behavior. 1. Cardinal utility analysis, and 2. Ordinal utility analysis. Preliminary notations and assumptions. A consumer in general consumes many goods, but for simplicity we shall consider the consumer's choice problem in a situation where there are only two goods, bananas and mangoes. Any combination of the amount of the two goods will also be called a consumption bundle, or in short, a bundle. In general, we shall use variable x1 to denote the quantity of bananas and x2 to denote the quantity of mangoes. x1 and x2 can be positive and 0. x1, x2 would mean the bundle consisting of x1 quantity of bananas and x2 quantity of mangoes. For particular values of x1 and x2, x1, x2 would give us a particular bundle. For example, the bundle 5-10 consists of 5 bananas and 10 mangoes. The bundle 10-5 consists of 10 bananas and 5 mangoes. Utility. A consumer usually decides his demand for a commodity on the basis of utility or satisfaction that he derives from it. What is utility? Utility of a commodity is its want-satisfying capacity. The more the need of a commodity, or the stronger the desire to have it, the greater is the utility derived from the commodity. Utility is subjective. Different individuals can get different levels of utility from the same commodity. For example, someone who likes chocolates will get much higher utility from a chocolate than someone who is not so fond of chocolates. Also, utility from one individual gets from the commodity can change with change in place and time. For example, utility from the use of a room heater will depend upon whether the individual is in Ladakh or Chennai, or whether it is summer or winter. Cardinal utility analysis. Cardinal utility analysis assumes that the level of utility can be expressed in numbers. For example, we can measure the utility derived from a shirt and say this shirt gives me 50 units of utility. Before discussing further, it can be useful to have a look at two important measures of utility. Measures of utility. Total utility. Total utility of a fixed quantity of a commodity Tu is the total satisfaction derived from consuming the given amount of some commodity X. More of commodity X provides more satisfaction to the consumer. Tu depends on the quantity of the commodity consumed. Therefore, TUN refers to the total commodity derived from consuming n units of commodity X. Marginal utility. Marginal utility, MU, is the change in total utility due to consumption of one additional unit of a commodity. For example, suppose 4 bananas give us 28 units of total utility and 5 bananas give us 30 units of total utility. Clearly, consumption of the 5th banana has caused total utility to increase by 2 units. 30 units minus 28 units. Therefore, marginal utility of the 5th banana is 2 units. MU5 equal 2U5 minus TU4 equal 30 minus 28 equal to 2. In general, MUN equal to 2UN minus 2UN minus 1, where subscript n refers to the nth unit of the commodity. Total utility and marginal utility can also be related in the following way. TUN equal MU1 plus MU2 plus so on till MUN minus 1 plus MUN. This simply means that TU derived from the consuming n units of bananas is the total sum of marginal unit of first banana MU, marginal unit of second banana M2 and so on till the marginal unit of the nth unit. Table number 2.1 and figure 2.1 shows an imaginary example of the values of marginal and total utility derived from consumption of various amounts of commodity. Usually it is seen that the marginal utility diminishes with increase in consumption of the commodity. This happens because having obtained some amount of the commodity, the desire of the consumer to have still more of it becomes weaker. The same is also shown in the table and graph. Values of marginal and total utility derived from consumption of various amounts of a commodity is shown in table 2.1. Notice that MU3 is less than MU2. You may also notice that total utility increases but at a diminishing rate. The rate of change in total utility due to change in quantity of commodity consumed is a measure of marginal utility. This marginal utility diminishes with increases in consumption of the commodity from 12 to 6, 6 to 4 and so on. This follows from the law of diminishing marginal utility. Law of diminishing marginal utility states that marginal utility from consuming each additional unit of a commodity declines as its consumption increases, while keeping consumption of other commodities constant. MU becomes 0 at a level when TU remains constant. In the example, TU does not change at fifth unit of consumption, and therefore MU5 equal to 0. Therefore, TU starts falling and MU becomes negative. Derivation of demand curve in the case of single commodity, law of diminishing marginal utility. Cardinal utility analysis can be used to derive demand curve for a commodity. What is a demand and what is demand curve? The quantity of a commodity that a consumer is willing to buy and is able to afford given prices of goods and income of the consumer is called demand for that commodity. Demand for a commodity X1 apart from the price of X itself depends on factors such as prices of other commodities. See substitutes and complements 2.44. Income of the consumer and taste and preferences of the consumers. Demand curve is a graphic representation of various quantities of commodity that a consumer is willing to buy at different prices of the same commodity, while holding constant prices of other related commodities and income of the consumer. Figure 2.2 presents hypothetical demand curve of an individual for commodity X at its different prices. Quantity is measured along the horizontal axis and price is measured along the vertical axis. Downward sloping demand curve shows that at lower prices the individual is willing to buy more of commodity X. At higher prices she is willing to buy less of commodity X. Therefore there is a negative relationship between price of a commodity and quantity demanded, which is referred to as law of demand. An explanation for a downward sloping demand curve rests on the notion of diminishing marginal utility. The law of diminishing marginal utility states that each successive unit of a commodity provides lower marginal utility. Therefore, the individual will not be willing to pay as much for each additional unit, and this results in a downward sloping demand curve. At a price of Rs 40 per unit X, individual's demand for X was 5 units. The sixth unit of commodity X will be worth less than the fifth unit. The individual will be willing to buy the sixth unit only when the price drops below Rs 40 per unit. Hence, the law of diminishing marginal utility explains why demand curves have a negative slope. Cardinal utility analysis. Cardinal utility analysis is simple to understand, but suffers from a major drawback in the form of quantification of utility in numbers. In real life, we never express utility in the form of numbers. At the most, we can rank various alternative combinations in terms of having more or less utility. In other words, the consumer does not measure utility in numbers, though she often ranks various consumption bundles. This forms the starting point of this topic, ordinal utility analysis. A consumer preferences over the set of available bundles can often be represented diagrammatically. We already have seen that the bundles available to the consumer can be plotted as points in a two-dimensional diagram. The points representing bundles which give the consumer equal utility can generally be joined to obtain a curve like the one in figure 2.3. The consumer is said to be different at the different bundles because each point of the bundles gives the consumer equal utility. Such a curve joining all points representing bundles among which the consumer is indifferent is called an indifference curve. All the points such as A, B, C, and D lying on an indifference curve provide the consumer with the same level of satisfaction. It is clear that when a consumer gets one or more banana, he has to forego some mangoes, so that her total utility level remains the same and she remains on the same indifference curve. Therefore, indifference curve slopes downward. The amount of mangoes and the consumer has to forego in order to get an additional banana, her total utility level being the same, is called marginal rate of substitution. In other words, marginal rate of substitution is simply the rate at which the consumer will substitute bananas for mangoes so that her total utility remains constant. So, MRS equal to one can notice that in the table 2.2, as we increase the quantity of bananas, the quantity of mangoes sacrificed for each additional banana declines. In other words, MRS diminishes with increase in the number of bananas. As the number of bananas with the consumer increases, the MU derived from each additional banana falls. Similarly, with the fall in quantity of mangoes, the marginal utility derived from mangoes increases. So with increase in the number of bananas, the consumer will feel the inclination to sacrifice small and smaller amounts of bananas. This tendency for the MRS to fall with increase in quantity of bananas is called law of diminishing marginal rate of substitution. This can be seen from figure 2.3 also. Going from point A to point B, the consumer sacrifices 3 mangoes for 1 banana. Going from point B to point C, the consumer sacrifices 2 mangoes for 1 banana. And going from point C to point D, the consumer sacrifices just 1 mango for 1 banana. Thus, it is clear that consumers sacrifice smaller and smaller quantities for mangoes for each additional banana. Shape of an indifference curve. It may be mentioned that the law of diminishing marginal rate of substitution causes an indifference curve to be convex to the origin. This is the most shape of an indifference curve. But in case of goods being perfect substitutes, the marginal rate of substitution does not diminish it. It remains the same. Let's take an example. Here the consumer is indifferent to all these combinations as long as the total of 5 rupee coins and 5 rupee notes remains the same. For the consumer, it is hardly matter whether she gets a 5 rupee coin or a 5 rupee note. So irrespective of how many 5 rupee notes she has, the consumer will sacrifice only 1 5 rupee coin for a 5 rupee note. So these two commodities are perfect substitutes for the consumer, and indifference curve depicting these will be a straight line. In the figure 2.4, it can be seen that the consumer sacrifices the same number of 5 rupee coins each time he has an additional 5 rupee note. Monotonic preferences. Consumers' preferences are assumed to be such that between any two bundles x1, x2 and y1, y2, if x1, x2 has more of at least one of the goods and no less of the other good compared to Y1, Y2, then the consumer prefers X1, X2 to Y1, Y2. Preferences of this kind are called monotonic preferences. Thus, a consumer's preferences are monotonic if and only if between any two bundles the consumer prefers the bundle which has more of or at least one of the goods and no less than the other good as compared to the other bundle. Indifference map. The consumer's preferences over all the bundles can be represented by a family of indifference curves as shown in figure 2.5. This is called an indifference map of the consumer. All points on an indifference curve represent bundles which are considered indifferent by the consumer. Monotonicity of preferences imply that between any two indifference curves, the bundles on the one which lies above the preferred of the bundles on the one which lies below. Features of indifference curve. Number 1. Indifference curve slopes downward from left to right. An indifference curve slopes downward from left to right, which means that in order to have more bananas, the consumer has to forego some mangoes. If the consumer does not forego some mangoes with an increase in number of bananas, it will mean consumer having more of bananas with the same number of mangoes, taking her to a higher indifference curve. Thus, as long as the consumer is on the same indifference curve, an increase in bananas must be compensated by a fall in quantity of mangoes. 2. Higher indifference curve gives greater level of utility. As long as marginal utility of a commodity is positive, an individual will always prefer more of that commodity, as more of the commodity will increase the level of satisfaction. Consider the different combination of bananas and mangoes. A, B, and C depicted in Table 2.4 and Figure 2.7 combinations. A, B, and C consist of same quantity of mangoes but different quantities of bananas. Since combination B has more bananas than A, B will provide the individual a higher level of satisfaction than A. Therefore, B will lie on a higher indifference curve than A, depicting higher satisfaction. Likewise, C has more bananas than B. Quantity of mangoes is the same in B and C. Therefore, C will provide higher level of satisfaction than B, and also lie a higher indifference curve than B. A higher indifference curve consisting of combinations with more of mangoes or more of bananas or more of both will represent combinations that give higher level of satisfaction. 3. Two indifference curves never intersect each other. Two indifference curves intersecting each other will lead to conflicting results. To explain this, let us allow two indifference curves to intersect each other as shown in the figure. As points A, B lie on the same indifference curve IC1, utilities derived from combination A and combination B will give the same level of satisfaction. Similarly, as points A and C lie on the same indifference curve IC2, utility derived from combination A and from combination C will give the same level of satisfaction. From this, it follows that utility from point B and from point C will also be the same, but this is clearly an absurd result, as on point B, the consumer gets a greater number of mangoes with the same quantity of bananas. So consumer is better off at point B than at point C. Thus, it is clear that intersecting indifference curves will lead to conflicting results. Thus, two indifference curves cannot intersect each other. The consumer's budget. Let us consider a consumer who has only a fixed amount of money to spend on two goods. The prices of the goods are given in the market. The consumer cannot buy any and every combination of the two goods that she may want to consume. The consumption bundles that are available to the consumer depend on the prices of the two goods and the income of the consumer. Given her fixed income and the prices of the two goods, the consumer can afford to buy only those bundles which cost her less than or equal to her income. Budget set and budget line. Suppose the income of the consumer is M, and the prices of bananas and mangoes are P1 and P2 respectively. If the consumer wants to buy X1 quantities of bananas, she will have to spend P1 X1 amount of money. Similarly, if the consumer wants to buy X2 quantities of mangoes, she will have to spend P2 X2 amount of money. Therefore, if the consumer wants to buy the bundle consisting of X1 quantities of bananas and X2 quantities of mangoes, she will have to spend P1 X1 plus P2 X2 amount of money. She can buy this bundle only if she has at least P1 X1 plus P2 X2 amount of money. Given the prices of the goods and the income of the consumer, she can choose any bundle as long as it costs less than or equal to the income she has. In other words, the consumer can buy any bundle X1 X2 such that P1 X1 plus P2 X2 is less than or equal to M. The inequality 2.1 is called the consumer's budget constraint. The set of bundles available to the consumer is called budget set. The budget set is thus the collection of all bundles that the consumer can buy with her income at the prevailing market prices. If both the goods are perfectly divisible, the consumer's budget set would consist of all the bundles X1, X2, such that X1 and X2 are any numbers greater than or equal to 0, P1 X1 plus P2 X2 less than or equal to M. The budget set can be represented in a diagram as in figure 2.9. All bundles in the positive quadrant which are on or below the line are included in the budget set. The equation of the line is P1 X1 plus P2 X2 equal to M. The line consists of all bundles which cost exactly equal to M. This line is called the budget line. Points below the budget line represent bundles which cost strictly less than M. The equation 2.2 can also be written as X2 equal to M by P2 minus P1 by P2 X1. The budget line is a straight line with horizontal intercept M by P1 and vertical intercept M by P2. The horizontal intercept represents the bundle that the consumer can buy if she spends her entire income on bananas. Similarly, the vertical intercept represents the bundle that the consumer can buy if she spends her entire income on mangoes. The slope of the budget line is minus P1 by P2. Price ratio and the slope of the budget line. Think of any line, any point on the budget line. Such a point represents a bundle which costs the consumer her entire budget. Now suppose the consumer wants to have one more banana. She can do it only if she gives up some amount of the other good. How many mangoes does she have to give up if she wants to have an extra quantity of bananas? It would depend on the prices of the two goods. A quantity of banana costs P1. Therefore, she will have to reduce her expenditure on mangoes by P1 amount. If she wants one more quantity of banana, with P1 she could buy P1 P2 quantities of mangoes. Therefore, if the consumer wants to have an extra quantity of bananas, when she is spending all her money, she will have to give up P1 by P2 quantities of mangoes. In other words, in the given market conditions, the consumer can substitute bananas for mangoes at the rate P1, P2. The absolute value of the slope of the budget line measures the rate at which the consumer is able to substitute bananas for mangoes when she spends her entire budget. The set of changes in the budget set. The set of available bundles depend on the prices of the two goods and the income of the consumer. When the price of either of the goods of the consumer's income changes, the set of available bundles is also likely to change. Suppose the consumer's income changes from M to M prime, but the prices of the two goods remain unchanged. With the new income, the consumer can afford to buy all bundles X1, X2 such that P1 X1 plus P2 X2 is less than or equal to M prime. Now the equation of the budget line is P1 x1 plus P2 x2 equal to m prime. Equation can also be written as x2 equal to m prime by P2 minus P1 by P2 x1. Note that the slope of the new budget line is the same as the slope of the budget line prior to the change in the consumer's income. However, the vertical intercept has changed after the change in income. If there is an increase in the income, that is, if m prime is greater than m, the vertical as well as the horizontal intercept increase. There is a parallel outward shift on the budget line. If the income increases, the consumer can buy more of the goods at the prevailing market prices. Similarly, if the income goes down, that is, if m prime is less than m1, both intercepts decrease, and hence there is a parallel inward shift of the budget line. If income goes down, the availability of goods goes down. Changes in the set of available bundles resulting from changes in consumers' income when the prices of the two goods remain unchanged are shown in figure 2.10. Now suppose the price of bananas change from P1 to P prime 1, but the price of mangoes and the consumer's income remain unchanged. At the new price of the bananas, the consumer can afford to buy all bundles x1, x2 such that P1 prime x1 plus P2 x2 is less than or equal to m. The equation of the budget line is P1 prime x1 plus P2 x2 equal to m. x2 equal to m by P2 minus P1 prime by P2 x1. Note that the vertical intercept of the new budget line is the same as the vertical intercept of the budget line prior to the change in the price of bananas. However, the slope of the budget line and horizontal intercept have changed after the price change. If the price of bananas increases, that is, if P1 prime is greater than P1, the absolute value of the slope of the budget line increases and the budget line becomes steeper. It pivots inwards around the vertical intercept and horizontal intercept decreases. If the price of bananas decreases, that is, P1 prime is less than P1, the absolute value of the slope of the budget line decreases and hence the budget line becomes flatter. It pivots outwards around the vertical intercept and horizontal intercept increases. Figure 2.11 shows change in the budget set when the price of only one commodity changes, while the price of the other commodity as well as the income of the consumer are constant. A change in the price of mangoes when price of bananas and consumers' income remain unchanged will bring out similar changes in the budget set of the consumer. Optimal choice of the consumer. The budget set consists of all bundles that are available to the consumer. The consumer can choose a consumption bundle from the budget set. But on what basis does she choose her consumption bundle from the ones that are available to her? In economics, it is assumed that the consumer chooses her consumption bundle on the basis of her taste and preferences over the bundles in the budget set. It is generally assumed that the consumer has well-defined preferences over the set of possible bundles. She can compare any two bundles. In other words, between any two bundles, she either prefers one to the other or she is indifferent between the two. Equality of the marginal rate of substitution and the ratio of the prices. The optimum bundle of the consumer is located at the point where the budget line is tangent to one of the indifference curves. If the budget line is tangent to an indifference curve at a point, the absolute value of the slope of the indifference curve, MRS, and that of the budget line price ratio are same at that point. Recall from our earlier discussion that the slope of the indifference curve is the rate at which the consumer is willing to substitute one good for the other. The slope of the budget line is the rate at which the consumer is able to substitute one good for the other in the market. At the optimum, the two rates should be the same. To see why, consider a point where this is not so. Suppose the MRS at such a point is 2, and suppose the two goods have the same price. At this point, the consumer is willing to give up 2 mangoes if she is given an extra banana. But in the market, she can buy an extra banana if she gives up on both the goods compared to the bundle represented by the point, and hence move the preferred bundle, thus a point at which the MRS is greater. The price ratio cannot be optimum. A similar argument holds for any point at which the MRS is less and the price ratio. In economics, it is generally assumed that the consumer is a rational individual. A rational individual clearly knows what is good and what is bad for her, and in any given situation she always tries to achieve the best for herself. Thus, not only does a consumer will have a well-defined preferences over the set of available bundles, she also acts according to her preferences. From the bundles which are available to her, a rational consumer always chooses the one which gives her maximum satisfaction. In the earlier sections, it was observed that the budget set describes the bundles that are available to the consumer, and her preferences over the available bundles can usually be represented by an indifference map. Therefore, the consumer's problem can also be stated as follows. The rational consumer's problem is to move to a point on the highest possible indifference curve given her budget set. If such a point exists, where would it be located? The optimum point would be located on the budget line. A point below the budget line cannot be optimum. Compared to a point below the budget line, there is always some point on the budget line which contains more or of at least one of the goods and no less of the other, and it is therefore preferred by a consumer whose preferences are monotonic. Therefore, if the consumer's preferences are monotonic, for any point below the budget line, there is some point on the budget line which is preferred by the consumer. Points above the budget line are not available to the consumer. Therefore, the optimum, most preferred bundle of the consumer would be on the budget line. Where on the budget line will the optimum bundle be located? The point at which the budget line just touches is tangent to one of the indifference curve would be the optimum. To see why this is so, note that at any point on the budget line other than the point at which it touches the indifference curve lies on a lower indifference curve and hence is inferior. Therefore, such a point cannot be the consumer's optimum. The optimum bundle is located on the budget line at the point where the budget line is tangent to an indifference curve. Figure 2.12 illustrates the consumer's optimum. At x1, x2, the budget line is tangent to the black colored indifference curve. The first thing is to note that the indifference curve just touching the budget line is the highest possible indifference curve given to the consumer's budget set. Bundles on the indifference curve above this, like the gray one, are not affordable. Points on the indifference curves below this, like the blue one, are certainly inferior to the points on the indifference curve just touching the budget line. Any other point on the budget line lies on a lower indifference curve and hence is inferior to x1, x2. Therefore, x1, x2 is the consumer's optimal bundle. Demand. In the previous section, we studied the choice problem of the consumer and derived of the consumer's optimum bundle given the prices of the goods and the consumer's income and her preferences. It was observed that the amount of the good and the consumer chooses optimally depends on the price of the good itself, the prices of other goods, the consumer's income, and her tastes and preferences. The quantity of a commodity that a consumer is willing to buy and is able to afford, given the prices of goods and consumer's tastes and preferences, is called demand for the commodity. Whenever one of or more of these variables change, the quantity of the good chosen by the consumer is likely to change as well. Here, we shall change one of these variables at a time and study how this amount of the good chosen by the consumer is related to that variable. Demand curve and the law of demand. If the prices of other goods, the consumer's income and her tastes and preferences remain unchanged, the amount of a good that a consumer optimally chooses becomes entirely dependent on its price. The relation between the consumer's optimal choice of the quantity of a good and its price is very important, and its relation is called a demand function. Thus, the consumer's demand function for a good is a relation between the two variables x and y such that for each value of x1 there is a unique value of variable y. In other words, fx is a rule which assigns as a unique value y for each value of x, and the value of y depends on the value of x. Y is called the dependent variable and x is called an independent variable. A function y equal to fx is an increasing function in the value of y and does not decrease with increase in the value of x. It is a decreasing function if the value of y does not increase with increase in the value of x. The function in example 1 is an increasing function, so is the function y equal to x plus 5. The function in example 2 is a decreasing function. The function y equal to 50 minus x is also decreasing. Graphical representation of a function. Deriving a demand curve from indifference curves and budget constraint. Consider an individual consuming bananas x1 and mangoes x2, whose income is m and market prices x1 and x2 are p1, p2 prime, respectively. Figure A depicts her consumption equilibrium at point C, where she buys x1 prime, x2 prime quantities of bananas and mangoes respectively. In panel B of figure 2.14, we plot P1 again x1 prime, which is the first point on demand curve for x1. Suppose the price of x1 drops to P1 with P2 and M remaining constant. The budget is set in panel A, expands a new consumption equilibrium on a higher indifference curve at point D, where she buys more bananas. Thus, demand for bananas increases as the price drops. We plot P1 against x1 in panel to get second point on the demand curve for x1. Likewise, the price of bananas can be dropped further to P1, resulting in further increase in consumption of bananas to x1, plotted against x2, gives us the third point on the demand curve. Therefore, we observe that a drop in price of bananas results in an increase in quality of bananas purchased by an individual who maximizes his utility. This demand curve for bananas is thus negatively sloped. The negative slope of the demand curve can also be explained in terms of the two effects, namely substitution effect and income effect, that come into play when price of a commodity change. When bananas become cheaper, the consumer maximizes his utility by substituting bananas for mangoes in order to derive the same level of satisfaction for a price change, resulting in an increase in demand for bananas. Moreover, as price of bananas drop, consumers' purchasing power increases, which further increases demand for bananas. This is the income effect of a price change, resulting in further increase in demand of bananas. Law of demand. Law of demand states that other things being equal, there is a negative relation between demand for a commodity and its price. In other words, when price of the commodity increases, demand for it falls, and when price of the commodity decreases, demand for it rises. other factors remains the same. Normal and inferior goods. The demand function is a relation between the consumer's demand for a good and its price when other things are given. Instead of studying the relation between the demand for a good and its price, we can also study the relation between the consumer's demand for the good and the income of the consumer. The quantity of a good that a consumer demands can increase or decrease with the rise in income depending on the nature of the good. For most goods, the quantity that a consumer chooses increases as consumer's income increases and decreases as the consumer's income decreases. Such goods are called normal goods. Thus, a consumer's demand for a normal good moves in the same direction as the income of the consumer. However, there are some goods the demands for which move in the opposite direction of the income of the consumer. Such goods are called inferior goods. As the income of the consumer increases, the demand for an inferior good falls, and as the income decreases, the demand for an inferior good rises. Examples of inferior goods include low-quality food items like coarse cereals. A good can be normal good for the consumer at some levels of income and inferior good for her at other levels of income. At very low levels of income, a consumer's demand for low-quality cereals can increase with income. But beyond a level, any increase in the income of the consumer is likely to reduce her consumption for such food items as she switches to better quality cereals. Substitutes and complements. We can also study the relation between quantity of a good that a consumer chooses and the price of a related good. The quantity of a good that the consumer chooses can increase or decrease with the rise in the price of a related good, depending on whether the two goods are substitutes and complementary to each other. Goods which are consumed together are called complementary goods. Examples of goods which are complement to each other include tea and sugar, shoes and socks, pen and ink. Since tea and sugar are used together, an increase in the price of sugar is likely to decrease the demand of tea, and a decrease in the price of sugar is likely to increase the demand for tea. Similarly, is the case with other complements. In general, the demand for a good moves in the opposite direction of the price of its complementary goods. In contrast to complements, goods like tea and coffee are not consumed together. In fact, they are substitutes for each other. Since tea is a substitute for coffee, if the price of the coffee increases, the consumers can shift to tea, and hence the consumption of tea is likely to go up. On the other hand, if the price of coffee decreases, the consumption of tea is likely to go down. The demand for a good usually moves in the direction of the price of its substitutes. Shifts in the demand curve. The demand curve was drawn under the assumption that the consumer's income, the prices of other goods, and the preferences of the consumer are given. What happens to the demand curve when any of these things changes? Given the prices of other goods and the preferences of a consumer, if the income increases, the demand of the good at each price changes, and hence there is a shift in the demand curve. For normal goods, the demand curve shifts rightward and the inferior goods. The demand curve shifts leftwards. Given the consumer's income and her preferences, if the price of related good changes, the demand of a good at each level of its price changes, and hence there is a shift in the demand curve. If there is an increase in the price of the substitute good, the demand curve shifts rightward. On the other hand, if there is an increase in the price of the complementary good, the demand curve shifts leftward. The demand curve can also shift due to a change in the taste and preferences of the consumer. If the consumer's preferences changes in favor of a good, the demand curve for such a good shifts rightward. On the other hand, the demand curve shifts leftward due to an unfavorable change in the preferences of the consumer. The demand curve of ice cream, for example, is likely to shift rightward in the summer because of preference for ice creams goes up in summer. Revelation of the fact that the cold drinks might be injurious to health can adversely affect preferences for cold drinks. This is likely to result in a leftward shift in the demand curve for cold drinks. Movements along the demand curve and shifts in the demand curve. As it has been noted earlier, the amount of a good that the consumer chooses depends on the price of the good, the prices of other goods, income of the consumer, and her tastes and preferences. The demand function is a relation between amount and the good and its price when other things remains unchanged. The demand curve is a graphical representation of the demand function. At higher prices, the demand is less, and at lower prices, the demand is more. Thus, any change in the price leads to movement along the demand curve. On the other hand, changes in any of other things lead to a shift in the demand curve. Market demand. In the last section, we studied the choice problem of the individual consumer and derived the demand curve of the consumer. However, in the market for a good, there are many consumers. It is important to find out the market demand for the good. The market demand for a good at a particular price is the total demand of all consumers taken together. The market demand for a good can be derived from the individual demand curves. Elasticity of demand. The demand for a good moves in the opposite direction of its price, but the impact of the price change is always not the same. Sometimes the demand for a good change considerably, even for small price change. On the other hand, there are some goods for which the demand is not affected much by price changes. Demands for some goods are very responsive to price changes, while demands for certain goods are not so responsive to price changes. Price elasticity of demand is a measure for the responsiveness of the demand for a good to changes in its price. Price elasticity of demand for a good is defined as the percentage change in demand for the good divided by the percentage change in its price. Price elasticity for demand for a good. Constant elasticity demand curve. The elasticity of demand on different points on a linear demand curve is different, varying from 0 to infinity. But sometimes the demand curve can be such that the elasticity of demand remains constant throughout. Consider, for example, a vertical demand curve as the one depicted. Whatever be the price, the demand is given at the level Q bar. A price never leads to a change in the demand for such a demand curve, and ED is always 0. Therefore, a vertical demand is perfectly inelastic. Factors determining price elasticity on demand for a good. The price elasticity of demand for a good depends on the nature of the good and the availability of close substitutes for the good. Consider, for example, necessities like food. Such goods are essential for life, and demands for such goods do not change such much in response to changes in the prices. Demand for food does not change much even if food prices go up. On the other hand, demand for luxuries can be very responsive to price changes. In general, demand for a necessity is likely to be price inelastic, while demand for a luxury good is likely to be price elastic. Though demand for food is inelastic, the demands for specific food items are likely to be more elastic. For example, think of a particular variety of pulses. If price of variety of pulses goes up, people can shift to some other variety of pulses, which is a close substitute. The demand for a good is likely to be elastic if close substitutes are easily available. On the other hand, if close substitutes are not available easily, the demand for a good is likely to be inelastic. Elasticity and expenditure. The expenditure on a good is equal to the demand for the good times its price. Often it is important to know how the expenditure for a good changes as a result of a price change. The price of a good and the demand for the good are inversely related to each other. Whether the expenditure of the good goes up or down as a result of an increase in its price depends on how responsive the demand for the good is the price change. Consider